We're now going to begin our final session of the day, integrating Jupyter Notebooks, version control, and GitHub Classroom.
Thank you, Tim, and all the TLT folks. I taught a class a little over a year ago where I had graduate students working on scientific coding. And for that, I wanted them to be able to get the benefits of interactive tutorials where they were able to write code, analyze data, and have the benefits of Jupyter Notebooks, which I'll describe a little bit. But I also wanted to make it possible for the effort I put in to be used by teachers elsewhere, for them to improve it between the time I taught it last time and the time I teach it next time, to be able to see the improvements that they made and quickly identify what changes they made, pick them, and integrate those in. And so that had two sort of goals. One of using a recent technology, Jupyter Notebooks, for having interactive lessons that I'll show later, and one of version control that weren't really compatible. And so the thing I'd like to share today is how I integrated those two. Thanks to everyone who completed the pre-session survey, because that informed me that I should say a little bit about each of these technologies first before diving into the combining. So the four tools that I'll talk about briefly are Git. That's a method for version control of documents. GitHub, an online platform for sharing and collaborating on documents that are controlled that way. GitHub Classroom, something that allows you to customize GitHub for a classroom environment. And Jupyter Notebooks, the sort of visual interactive format for sharing these things. Okay, so first maybe I'll take Git in turn. So what is Git? It's for distributed version control. So if you were the only instructor for a class, you could just have your document, Word file, PowerPoint, whatever you want, and you can just update every semester, save a version at the end of the class, and you don't really need to have a fancy version control system. Maybe you'd save the version you use each semester so you could go back and pick something. But what if you have multiple people collaborating on it? Say you have multiple instructors teaching the same class a given semester, or maybe a class is only taught once every 2 years. And between the time you teach it at Penn State and a colleague at another university teaches a similar class and picks one of your lessons and they make some improvements, well, how are you gonna get all those improvements without having to review everything? I know I teach a class where I take turns with another instructor, and each of us will make improvements, but it's a real pain to go through and just find all the changes they made, some of which are sort of inconsequential, just the name or the time of a section, and others of which may be how much content in a particular area that you may want to either keep your preferences for when you teach the class or take advantage of the changes they made. And so Git allows for this. It was originally designed for software development, big projects like the Linux kernel, but it's now widely used for many things like small software packages, but also documentation. Websites are now version controlled and developed using Git, and even workflows for, say, data analysis processes. In educational setting, I think the things that come to mind for us, some of the responses from your surveys, we're preparing reading materials, lessons for students, where maybe each semester a few things get updated. Maybe just your syllabus, where some things have to change every semester, but some things stay the same. Assignments, where the students don't just read something, but they change it, and you want to be able to quickly see what did the student change to, say, the introduction lab tutorial, the framework, and fill in that template. Or maybe a tutorial where they were supposed to experiment and try some things, or even presentations. If anyone's curious, you can see the source for this presentation in the links at the end. So GitHub is an open source, it's a sort of a standard web platform for sharing open source software. You can use it just to download stuff, but more importantly, if you want to contribute back to a project. So you see something and you go, hey, I have a little idea as to how to improve it. Maybe it's as simple as you find a typo in their instructions. Maybe it's as complicated as you add a new feature. Either way, you're able to see what they have, identify a change you'd like to suggest, send what's known as a pull request saying, hey, I think you should incorporate this, and then people can review it, they can discuss it, and eventually go ahead and put that into the project that everyone gets to look at. And so this would be great for, say, a class project where you might have multiple students working on the same project. Maybe they're contributing things that are mostly independent, but there's some overlap, and this would be important for them to collaborate. Alternatively, the collaboration between the instructor and the student. They submit an assignment, you provide feedback, they then revise the assignment and iterate multiple times. The user interface changed in like the last week a little bit, so it won't look exactly the same if you go there, but there's a demo repository. You can sort of see what that's like here if anyone's interested. And the links are all in the description for the session as well. Oh, I meant to copy and paste that, sorry. I'll do that at the end so that people will. Let's see if I can do it quickly into the chat here. Okay, there you go. It's showing the chat as well. Okay, so the final piece of the puzzle is GitHub Classroom. So what's that? Well, GitHub is usually used for open source projects. Maybe in the corporate environment, you get a paid subscription. GitHub Classroom allows you to have private repositories, so students see their work and you see their work, but the rest of the world doesn't see either their work or your comments on their work, particularly if there's like rating information going around. And so that's a very valuable service. Also, it just makes it easier to administer a large class where you might have to broadcast to many students. So for example, here's a screenshot where I start with a list of the various assignments I had made. I can then get a link that I send to the students at the beginning of each lab session. They click on it, and then they get a starter template that they work from, and then I can check in on the status of all and see how everyone's doing and go to their project from a common web page there. So it's mostly just a tool to make it easy for us to manage lots of students working on an assignment in a classroom setting. Okay, then so all those were designed to work together. Those first, GitHub, GitHub Classroom, they were designed to work together, and they work together pretty well. Jupyter Notebooks, on the other hand, was not made to work with Git, and so it's a complementary, but doesn't integrate as seamlessly. So Jupyter Notebooks provide a browser-based experience where students can have an interactive session that can be for code development. It can be for reading text that might have integrated equations, plots, code, particularly if they want to change one parameter, say of a model, and see how it changes. Maybe they have a slider, maybe they have actual code they type in. Either way, they can quickly see what the changes they input cause, so a way to facilitate that active learning and experimentation. It's very flexible. The name references 3 programming languages, but it supports over 40 and probably more by now languages. So it can be very flexible from very simple languages for maybe environments where you want to keep things simple to very powerful ones for a software type class. One strength and weakness is it uses the JSON format to have a complete record of the user session. So there's a lot of metadata that isn't displayed to the user. That's great because you can then open a notebook and resume there, and we'll see why it creates problems. In the links I sent, I provided a sort of link that will show you a Jupyter Notebook as a read-only document if you want to just kind of see what I'm talking about, where I put some demonstration of some text, some equations, some functions that students might modify, a plot that they can look at to see how this interacts with. And then there's an interactive link via Binder, so you don't have to install any software on your own session, on your computer, but rather can interact with that notebook directly to get a feel for it. This could also be good for small, computationally minimal requirements in a classroom where you don't want everyone to have to install stuff on their computer. If it's a more involved class where they're going to be doing data analysis, you probably either want them to install it locally or use something like the ICDS ACI environment so they all have a common environment. So what is the Jupyter Notebook good for? Well, it's commonly used in like data sciences where people have to manipulate, clean up, visualize, transform data, do some exploratory data analysis, visualization, statistical modeling, machine learning, providing a report to whoever the customer client management is. Some people use it for interactive development environments. I'm not a big fan of that. That's a whole nother discussion. But all those things in a sort of corporate environment translate to an educational setting where we want to provide active learning experiences where there's an interactive lesson, where instead of just reading, partway through, there's something for them to do, for them to engage with, get a quick check on whether or not they understood what they just read. Maybe there's something where they're supposed to change something and see if they learned what they were supposed to do from the previous session and experiment a few times to get it right. It's also particularly good if you want them to be analyzing data or have some computation because you can integrate the instructions and the experimentation in one flow rather than going back and forth between, say, a document and a code editor or something. And it's also great because people can provide a document that justifies their decision-making process. So they can integrate in, here's the input data you gave me, here's the manipulations I did to that data, here's the plot I made, and then they can describe in their response, here's the choices I made about decisions I made from that analysis. And so it's great for, say, a lab notebook type setting where there might be a lab either in person or virtual, and the students explaining how they reach their conclusions. I think I didn't show where. Okay, well, so what's the problem with this? Well, the problem is because these Jupyter Notebooks contain so much information, comparing two versions of a Jupyter Notebook is very difficult. There's a lot of metadata that renders comparisons basically not human readable, and it's very hard to find the differences. So to illustrate that, I made just a few small changes to the example notebook I shared in that repository. And if I compare them on GitHub, I see the version on the left and right, and the things in red went away, and the things in green appeared. And none of that was something I care about. I'd have to keep scrolling down and down to find the few lines I actually changed that are important. And so because it's hard to compare them, it's very hard to see, well, what's changed, either from the last semester or since the student engaged in the tutorial. So what do I want to do about that? I want to come up with a solution that allows me to have the benefits of a Jupyter Notebook for a learning environment and the benefits of version control for instructors to effectively maintain, upgrade assignments, and to also compare student submissions to the starter templates they provide. And so the basic solution I came up with was to convert these Jupyter Notebooks to a Markdown representation. And Markdown strips away a lot of that metadata so that then when we compare those two versions, instead of getting a bunch of mumble jumble, you can very quickly see, oh, the student replaced the 2 zeros when they were told to replace these with their answers to their question with 2 numbers. Yep, those 2 numbers look good. They replaced 2 zeros here with 2 expressions, and I can see what they entered to decide if I like it, if it's correct, if I want to comment on it. And so that makes it a lot easier to compare things, whether it's you, another instructor, or a student. From this pre-course survey, I realized that lots of people weren't familiar with Markdown. Markdown in some ways is basically just text with a few little shorthands for how to indicate formatting, things like links and formatting, equations and images. And so, for example, this slide here just sort of has several different things to illustrate it. In Markdown would look like this. And so you're able to read that as a human, even though maybe the square brackets and parentheses, they're basically minimally distracting. And so it's possible to read Markdown, and therefore it's possible to compare Markdown quite easily. The actual process of all the details of implementing this, combining them, is detailed in the repository I shared with you as a README file that goes through each step of the way with command line instructions. That you can follow. So for here, I'll just give a sort of big picture overview of the process. The first step is the instructor creates a template repository. So this is a set of files that might just be a single file. It might have several components, maybe input data, maybe licensing information if there's code that's being or data that's being borrowed from other sources, maybe various tests so that you can see if the students are meeting your expectations with their responses. And that's distributed via a link via GitHub Classroom. So basically every week I would email the students, here's this week's tutorial. They would click that link, and then GitHub Classroom would generate their own private copy of that starter template starting from exactly where I sent it to them. What do I put in there? I would typically put a Jupyter Notebook, both in the original Jupyter Notebook format and in the Markdown format that's going to allow us to make easy comparisons. Any other files that are needed, as I mentioned before, and of those, the one I found most valuable was including tests. So I could say, oh, when they've successfully completed Lab 1, they should have the following variables set in their notebook. And so I could write a test that would then check those variables. Or I could even call functions if they wrote a new function and see if it gave the correct answer to various test cases. And by doing that, the students are able to run them tests themselves, get instantaneous feedback, even if it's 2 in the morning on Sunday, whether or not they pass the tests, and if they are sufficiently motivated, they can try to solve it on themselves before they get a negative grade. And then they can also help me. If I get a submission, I can quickly see, yep, it passed all the tests. Very good. I can focus on sort of next level improvements, or oh, they made a mistake on question 5, and I go straight there to see what I need to help them with. The student then completes the assignment in the Jupyter Notebook. Hopefully they take advantage of those tests I provided so they can do some self-tests and identify any shortcomings. And sort of here's an example of what one of those notebooks might look like when there's something that goes well, and they can also have cases where they're, oh, did I lose error slide? Okay, well, sorry. There's also, if there's errors, they get error messages telling them what test they did not pass. So once the students are happy with that, they convert their Jupyter Notebook back into a Markdown format that facilitates this this comparison. In my class, I just had a few command lines. Students ended up making scripts to automate it for them. I could imagine making even more automated in the future. And then they submit that to GitHub and issue a pull request indicating that they've submitted the assignment. And that's where the discussion begins. At that point, they can see if their test pass, or their code passes. For example, in this case, there's a red warning saying the checks have failed. And they can click on that and then get a message and see, oh, it was this test that failed. They were expecting that the certain variable would have some outcome. It didn't. And then they can go back and revise that if they wanted to, or see at least why they didn't get full credit later if there's not time for them to do that. So that automated testing, it's great, very reassuring when it says your code passed all the tests or your lab assignment. And so that's great. And at that point, then we can use the GitHub interface to discuss the assignment collaboratively. So instead of having to say, on page 7, line 5, paragraph 2, line 5, the second, whatever, and you've spent like half of your time writing about things that are just saying where they are, in GitHub, you can see the inputs on the left, the changes they made on the right in green. You can click on the exact lines you want to comment on, insert a comment. They can see that. They can choose to get notified right away or return to it later. And then they may respond. But of course, this can go on asynchronously. You may have now looked at many other students and be completely forgotten what you were talking about with them. But you can go back and you have a record of the entire conversation. You can see the changes they made in response to your suggestions, and have a valuable set of feedback based on the history of discussion around each of the comments you provide on their submissions. If you want detailed step-by-step instructions, I'll refer you to the links there. I think here, what might be useful is to think about how we could improve this going forward. So as it was, I have a process where I basically made a checklist for myself so that each week I wouldn't forget something. But there were a few changes. I would make a solution set first, and then I would take the solutions and basically strip out the solutions and say, to do, insert your response here. And that could be automated. If I had a larger class or was going to rolling this out, that might make sense. For my context where I had upper level students, it wasn't a problem for the students to execute a few commands to generate the Markdown version of their notebook. If you're doing it in a general education setting, or maybe a much larger class where you might have an increased number of students encountering technical difficulties, you might want to automate that process. I'm pretty sure you could do that via Git hooks. The downside of that would be that then the students don't really understand what's going on, and so they wouldn't necessarily learn so much about how Git works and how they might use it in the future. One of the surprising things I found the first time I taught a precursor to the class I'm describing, one of the things the students reported being most valuable was getting in the habit of using Git, of all things, which wasn't one of the explicit learning goals, but that was what they found was valuable. And so the next time I taught the class, I thought about how to make that really a part of the class rather than just a sideshow. And so I didn't want to take that away. I wanted them to engage with that. But for a different audience, that might be a little bit of a barrier. Since the time I taught this class, there's been a few new offerings. There's NBDime is a tool that allows you to directly compare Jupyter Notebooks visually. So that's good if you, say, are working by yourself. It required, the setup is such that it wouldn't really integrate in the same way that the Markdown diffs we're able to work with. So I think it could be good on its own, but not sort of integrating all four of these things. There's a commercial web service, NB Review, I learned about that looks very good if you were in a development environment, maybe in your research group where you wanted to be able to compare and collaborate students or advisees, postdocs working on Jupyter Notebooks. It is a commercial project. I asked if they would offer educational discounts, and they said they thought they were already competitively priced and didn't want to do that. I think it did meet the goal of comparisons, but because of the way it was, I'm not sure how well it would integrate with some of the needs of an educational setting, like having private repositories and be able to provide feedback to students. Someone provided a helpful hint in the survey, and I learned from them about Illumidesk. Illumidesk looks like a mechanism for auto-grading that is designed to integrate with Canvas. So if you didn't need the version control aspects, such as the NB-DIME and NB-Review sort of addressed, but wanted to take advantage of the ability to have sort of assignments auto-graded in some sense, then that looks like it's designed to do that part of it, and probably does it more intuitively in a prettier interface than the current session. But I will say that the students really appreciated the tests. And the other thing it demonstrated was sort of leading by example, because I was telling them, when you do your final class project, I want you to have tests so that if someone makes a mistake, you or a collaborator, you'll be able to quickly identify those problems rather than it sort of introducing a bug that affects you way down the road. And so by sort of modeling that behavior of incorporating tests, it had both the immediate benefits of providing them with instantaneous feedback and also the meta benefits of encouraging them to adopt that in their own use cases down the road. So that's something I've found worked out really well. And with that, I'd like to leave a little bit of time for discussion. That could be other approaches to this problem of how to version control curricular materials. It might not be entirely Jupyter Notebooks. There may be other formats that people have struggled with and found a workaround to make work. There might be other applications where a similar approach would be useful that I haven't thought about, coming from a sort of STEM field. And if any of the tools that were discussed, people have questions of individually, that's fine too. Some of those might extend beyond the session, but I'm happy to take those either now or follow up. Okay, so the question and answers I see, does version control only work with text files? Or can you use Excel files? So with something like Git, you can version control something like an Excel or Word file. The problem is because they're binary formats, if you make a relatively small change, something like, I change one sentence, it will see, oh, a whole bunch of bits and bytes changed, and you won't be able to do that easy comparison I showed. And so for that, something like the words track changes would be more valuable than using Git. On the other hand, if it's really just a text file or really just a spreadsheet of numbers, then maybe instead of using Word or Excel formats, you could use an ASCII format or a CSV format, which then does allow you to have Git not just keep all the versions available for you to go back to, but also allows you to highlight those lines that changed and sort of allow you to focus on those aspects. Similarly, I suspect any of other files like SolidWorks or AutoCAD, I'm guessing most of those are binary and have lots of metadata. So if you just want to be able to go back to where you were at any point in the past, and maybe you made 5 changes, something's broken and you don't know when that happened, and it would be great if you could go back and see, oh, it happened between change 3 and change 4, and you don't have to spend the time human doing it. So any sort of version control would work for that. Git sort of ability to see the small differences, I suspect, wouldn't work. But maybe if you had like an AutoCAD script, then version controlling those scripts with Git would allow you to see just the lines you changed well. Any other questions? Alrighty, well, thanks to everyone, and particularly those of you who provided some feedback early on. And feel free to get in contact with me if you have suggestions, or either suggestions or questions about how you might do something along these lines. And the links I put in the chat have the slides, which have also links to several resources for learning about all of these resources and tools if you want to use anyone individually as well as a group. So. Thanks, everyone.
Thank you, Eric, for sharing the ways you've used Jupyter Notebooks and GitHub Classroom to enhance your teaching and your students' learning. We want to thank all of our presenters today for sharing their work with our audience and continuously striving to improve the learning experience for all of our Penn State students. And lastly, thank you to our audience members for taking the time to join us this morning. We look forward to seeing you all in our next session.